Hey guys, this video is in response to some requests to do just a few more stoichiometry problems, just so you guys can have a little bit more practice. So I have 3 problems here today that I'm going to go through from beginning to end. I am working with a new little holder here for my iPad, so this could go off the rails. I think I've got everything where I want it, so if things go a little sideways on the screen, I'm going to apologize in advance. So let's take a look at this first problem. Aluminum hydroxide is often present in antacids used to neutralize stomach acid, which is HCl, forming a salt and water. If 20 grams of aluminum hydroxide is present in an antacid tablet, determine the maximum mass of water that will be produced. Assume excess hydrochloric acid. So what it looks like I have here is a double displacement reaction. More specifically, it looks like an acid-base neutralization reaction. I have the acid, HCl, and I have the base, aluminum hydroxide. So I already know how to handle these. If you aren't sure, if you're a high school student, you can probably look in your reference table packet and it will tell you how to handle a double displacement reaction right here, but we're going to go through it just to give you a little bit of a refresher. So aluminum hydroxide is AlOH3. I crisscrossed aluminum with a +3 with hydroxide that has a -1. We are adding to that hydrochloric acid, which is HCl. And what we know is going to happen here is the 2 outer ones are going to crisscross together and the 2 inner ones. So when I put aluminum with a +3 with chlorine with a -1, that's going to give me AlCl3. Plus, we know when we put hydronium with hydroxide, we are going to get water. Now, before I balance this, the next thing I like to do, I think this is great for beginning chemistry students, is I'm going to go ahead and figure out all these molar masses real quick so that when I need them, I have them. So if I add the mass of 1 aluminum to 3 oxygens and 3 hydrogens, that is going to give me 78.01 grams per mole. I'm not going to write the gram per mole down. This is really just my scratch work. The mass of HCl is the mass of 1 hydrogen added to the mass of 1 chlorine. That is 36.46 grams per mole. Aluminum chloride, 1 aluminum plus the mass of 3 chlorines is 133.33 grams per mole. And most of us know that the mass of water is 18.02 grams per mole. If you're watching this video and you don't know where I'm getting these numbers, watch my video on molar mass. It'll walk you right through it in just a few minutes. Next thing we're going to do is we're going to balance this equation. And the reason we balance the equation is we have got to be able to figure out what coefficients go in front of these formulas. We're satisfying the law of conservation of matter or the law of conservation of mass when we do this. And we need those coefficients because that's how we are going to get the numbers in the mole-to-mole ratio. And stoichiometry is all about the mole-to-mole ratio. That's really the most important step in this problem. So let's take an atom inventory. On the left, I have aluminum, oxygen, hydrogen, and chlorine. On the right, I have aluminum, oxygen, hydrogen, and chlorine. Let's count up how many of each we have. On the left, I have 1 aluminum, 3 times 1 is 3 oxygens, 3 times 1 is 3 hydrogens, plus 1 more here, which is a total of 4, and I have 1 chlorine. On the right, I have 1 aluminum, I have 1 oxygen, 2 hydrogens, and 3 chlorines. So now I'm going to get this thing balanced so I can actually get down to the business of solving the problem. So it looks like here I've just got 1 chlorine and over here I've got 3. So I'm going to try a 3 there. That may or may not be a good educated guess. Sometimes it doesn't work and you have to go back and fix it, but we're going to start with that. 3 times 1 is 3 hydrogens plus 3 more is a total of 6. And 3 times that understood subscript of a 1 is 3 chlorines. So I have fixed the chlorines. Aluminums are good. I need to work with this oxygen and hydrogen. Think I'm going to try a 3 right here. 3 times 2 is 6 hydrogens, and 3 times 1 is 3 oxygens, and that actually fixed everything. So my mole to mole ratio is going to come from these numbers. Now we don't typically write them, but you know that's an understood 1 and that's an understood 1 as well. So what I want to do is look at this problem and pull out 2 main things. What did they give me and what do they want? They gave me 20 grams of aluminum hydroxide. So this is what they've given me. They have asked me to find the mass of water. So they're asking me to find this. If you will pull those 2 things out of the problem, it really makes your life a lot easier. What they gave me and what they want. They gave me aluminum hydroxide, they want water. That is a 1-to-3 ratio, or if you flipped it, it would be a 3-to-1 ratio. When we are ready for that mole to mole ratio in our problem, this is where we're going to get it. So over here to the side, I'm just going to jot this down. We have 1 mole of aluminum hydroxide to every 3 moles of water. You do not have to write that down. Some beginning chemistry students find that helpful. Now, you may have to flip it when you put it in the problem, but you'll know how to do that when you get there. So let's go ahead and solve this problem. I have started with 20 grams of aluminum hydroxide. It is so important that you label every single thing. That's going to help you keep up with your work. I've done this for most of my life, I feel like, and if I don't label everything, I'll make a mistake. So that's just good practice. Now, because the given is in grams, I cannot multiply by the mole to mole ratio yet, because a gram is not going to cancel with a mole. So I need to convert using the molar mass from gram to mole. I've already found the mass of aluminum hydroxide. It was 78.01. So there's 78.01 grams of aluminum hydroxide per mole of aluminum hydroxide. Now I want you to notice that is an understood 1, but I did not put a 1 with mole there. Anytime you are doing a gram to mole or mole to gram conversion, do yourself a favor, do not put a number with the word mole. You want to only have a number in front of the word mole when you're dealing with the ratio, because then it stands out as specifically the mole to mole ratio. Grams cancel, and now I'm working with moles of aluminum hydroxide. Now that I'm in moles, I have permission to multiply by the mole to mole ratio. That's why I had to get this into moles. If they would have given me moles to start with, I would not even have to do this step. If they give you grams, convert it to moles. Now, here's my mole to mole ratio. I've already figured that out. I'm going to have the moles of aluminum hydroxide on the bottom, because remember, whatever is on top, when we do dimensional analysis, factor label, whatever you want to call it, whatever's on the top here is always on the bottom in the next slot. So I have 1 mole of aluminum hydroxide to every 3 moles of H2O. Now what this step has done, this is so important, I have now switched substances. Instead of working with aluminum hydroxide, I am now working with water, and they want the answer in terms of water. They want to actually know the mass of water, which means I'm going to have to do one more step. I'm going to have to convert my moles to gram. That's an easy conversion. A mole of water has a mass of 18.02 grams. Just about to run out of room here. Moles cancel, and now I'm ready just to calculate everything up. If you multiply 20 times 3 times 18.02, hit equals, divide that total by 78.01, your answer is going to be 13.86 grams of water. Now, one thing I cannot emphasize enough, and this is because for beginning chemistry students, this is typically where you're going to see a mistake, is this mole-to-mole ratio. You absolutely have to convert your given to moles so that this mole will cancel with this mole. If you would have left this step out, you would have been trying to cancel a gram in a mole, and that's not going to work. Also, when you do that gram-mole conversion or mole-to-gram conversion, remember there's no number with the word mole. The mole-to-mole ratio is the only step where you use these numbers from your balanced equation. That's it. And once you've done that, you've switched your substances, and your gram to moles are just a plain old mole, no number in front of them. That's just a rookie mistake. You know, as a teacher, you expect it. I probably made that mistake myself when I was a student, so I always like to emphasize it. All right, let's try another problem. So this problem says, excess lithium metal reacts spontaneously with bromine to produce lithium bromide. If 35 grams of bromine reacts, what mass of lithium bromide will be produced? I can pretty quickly tell you that this is going to be a synthesis reaction because I'm literally just putting a metal with a non-metal, and they actually told me what the product was, so that's going to make your life even easier. So lithium metal is just plain old Li. Now, they use the word bromine. This is where you've got a little responsibility as a chemistry student. They are expecting you to know that you have to put a 2 with that because bromine is one of those special diatomic gases. If you're one of my students, you've memorized that. They tell me that we get lithium bromide. Lithium has a +1. Bromine has a -1. So when you crisscross those, the ones cancel and you get LiBr. Next thing we want to do before we move on is we want to go ahead and calculate up those masses. So lithium, just look on the periodic table, it has a mass of 6.94 grams per mole. Bromine, you're going to multiply that mass by a 2, so that is 159.8 grams per mole. And then lithium bromide is 86.84 grams per mole. So next thing we want to do is we want to balance this. So it's going to be pretty quick to balance. A lot of you could probably just eyeball this and do it really quick, but since I'm teaching a lesson, I'm going to be just a little more thorough here. So let me go to a red pen so you can see these coefficients very clearly. We have 1 lithium, we have 2 bromines, 1 lithium, 1 bromine. I'm going to put a 2 here. When you put a number in front, it changes everything. 2 times 1 is 2 lithiums. 2 times 1 is 2 bromines. Pop a 2 in front of lithium and you are good to go. Remember, you don't write it, but this is an understood 1 in front of the bromine gas. So it looks like they gave me 35 grams of bromine. And again, you're talking bromine gas, so they gave me this. And the problem is asking me to solve for lithium bromide. They're just saying, hey, if you have 35 grams of bromine gas, plenty of lithium, don't worry about it, how many grams of lithium bromide can you make? These are the 2 things I'm comparing. What they gave me, what they want, so that's going to be my ratio. Just for fun, we'll write it out to the side. You're going to have 1 mole of bromine gas per every 2 moles of lithium bromide. When it comes time for you to plug that mole-to-mole ratio in the problem, that's what you're going to use, knowing you might have to flip it. We'll just know that when we get there. So let's go ahead and start. We always write down the given first. We have 35.0 grams of bromine gas. It's in grams. I do not have permission to multiply by the mole-to-mole ratio, so I'm going to have to get that into moles. The mass of bromine gas is 159.8 grams bromine gas per mole. Make sure you label that bromine gas so you can keep up with what you are working with. Grams cancel. I am now working in terms of moles of bromine gas. That means I have permission to plug in this mole to mole ratio. The bromine gas is going to have to go on the bottom because it was on the top here. You can also think about it like this. It's always what they gave you to what they want. What they gave you is on the bottom, where you're going is on top. So 1 mole of bromine gas to 2 moles of lithium bromide. That is your mole to mole ratio. That is the heart of the problem. And remember, these numbers came from the coefficients in the balanced equation. This is where we have switched substances. I am no longer working with bromine gas. Now I am working with lithium bromide. We've got one more step, and the reason we have one more step is the problem asks us to solve for mass. And when they ask you for mass, they want grams. If this problem would have said how many moles of lithium bromide are formed, you could stop right there. And sometimes you'll have a problem like that. But this problem wants grams. Maybe the person that's going to actually have to weigh it out. They've got to get their hands on it. So a mole of lithium bromide has a mass of 86.84 grams. They asked me for mass of lithium bromide. Once you write that down on top, that's kind of like your stop sign. You are done. So what you're going to do is multiply everything on the top together, everything on the bottom together, divide top by bottom. So really all you're doing here is saying 35 times 2 times 86.84, and then you are dividing that by 159.8. And your answer is 38.0 grams of lithium bromide. And that's it. We are going to run through one more example. Hopefully you're feeling a little bit more confident now. Now I'll tell you, this next one looks like a mess up front, but you'll see they really gave you everything that you need. In the commercial production of the element arsenic, arsenic 3 oxide is heated with carbon, which reduces the oxide to the metal according to the following unbalanced equation. They just told me it was unbalanced, so I know I'm going to have to do that. So let's go ahead and deal with that. I'm going to write down As2O3 plus carbon yields CO2 plus arsenic. Let's go ahead and get this thing balanced out. We're going to take an atom inventory. We have arsenic, oxygen, and carbon. Repeat the list in the same order on the other side so that you can compare across. That will make your life easier. I'm going to go pretty fast because I know you guys know how to do this balancing now. I have 2 arsenics, 3 oxygens, 1 carbon, 1 arsenic, 1 carbon, 2 oxygens. So looks like probably the first thing I think I'm going to try is I'm going to throw a 3 right here. That gives me 3 carbons, 3 times 2, 6 oxygens. If I put a 3 here, that's a really easy fix for that one. And I think what I'm going to do is maybe try a 2 here. 2 times 2 is 4. Oh, good. 2 times 3 is 6. Put a 4 here, and we are good to go. Would that have been the best place to start? Maybe, maybe not. There's always more than one way to do it. That's just happens to be what I pick, and it worked out. All right, so let's take a look at what the question actually says. If 15 grams of As2O3 are reacted with excess carbon, that just means there's plenty of it. Calculate the mass of both products. Oh, so you got a little bonus here. They want to know grams of this, and they want to know grams of this. So my first ratio will be between As2O3 and CO2. That'll be my first one. And then my second problem, I'm going to solve for arsenic, so it will be between this one, the given, and this. So let's solve for carbon dioxide first. This is not any more difficult. It's just a little more work because they want us to find both products. So the given is 15 grams of As2O3. It's in grams. I do not have permission to multiply by the molar-mole ratio, so I'm going to convert gram to mole. And I did forget to write these masses down, so I already have these done. So let me just jot these down for you. This was 197.84. You know that carbon is 12.01. You know that CO2 is 44.01. And arsenic is, I think 74.92 is that mass. Let me double check that. Yep, that's right. Okay, so now we're going to go from gram to mole. So there's 197.84 grams of As2O3 per mole. And when I had to just stop and do those masses, you can see why it's so nice to have that done beforehand, because you can just keep on cruising. You don't have to make that little pit stop. Now, I've got this in moles. I have permission to multiply by the molar-mole ratio. Because I am solving for CO2, this is what they gave me and this is what they want. So my ratio is a 2 moles of As2O3 on the bottom, and I'm going to 3 moles of carbon dioxide on the top. So 2 moles of As2O3 to 3 moles of CO2. They wanted the answer in terms of mass. So I'm going to do one more step, and I know that a mole of carbon dioxide has a mass of 44.01 grams per mole. So what I'm going to do is I'm going to multiply everything on the top together, write it down, multiply everything on the bottom together, and write it down. And when I do that, I'm getting 1980.45, that was the top, divided by 395.68, that was the bottom, multiplied together. So my total mass of carbon dioxide is 5.01 grams. Not very much. Now, I have one more problem to do. They also want to know, and this makes sense if you're actually making arsenic, you want to know how much you're making. They want to know if I have 15 grams of this, how much arsenic can I make? So this is going to be a 2-to-4 ratio when we get to that point. So let's solve for this one. I've got 15.0 grams of As2O3. We're starting off just like we did in the first one, because we still have to convert grams to mole. There's 197.84 grams of As2O3 per mole of As2O3. I want to point this out again. I know I sound like a broken record, but when you do gram to mole, don't put a number with that word mole. We all know it's a 1. Now that I've got it in moles, I have permission to multiply by the molar-mole ratio. I have 2 moles of As2O3 to every 4 moles of arsenic. I'm not done. They don't want the answer in moles. They want it in grams. Last step, and we are just about there. A mole of arsenic has a mass of 74.92 grams. All right, I'm going to grab an extra piece of paper here because I am running out of room. We're going to do this math and we're going to finish this problem. So I'm going to multiply everything on the top together, and when I do that, I'm going to get about 4,495.2. Then I'm going to multiply everything on the bottom together. We already know that is 395.68. Divide the top by the bottom, and you get 11.36 grams of arsenic. Again, I have said this before, but when you are looking at these stoichiometry problems, remember, these are nothing but recipes. recipes just like you are used to using in your kitchen, only a lot of the time it's going to be chemicals and things. You may not know what AS2O3 is. Most of you probably know what carbon dioxide is, but you don't have to really know to do these problems. You've just got to be able to work with the labels, work with the units, and cancel things out. So again, I want to emphasize stoichiometry is all about that mole to mole ratio. You have to convert the given to moles if it's in grams, just like all of these problems, so that you can cross this mole bridge. The mole bridge gets you from the substance they gave you to the substance they want. The substance they gave you to the substance they want. And then if the problem requests that you put it in grams, just do a real easy mole gram conversion at the end. This stuff on the far end of either problem, this is just housekeeping. You guys know how to go back and forth between gram and mole. This is the heart of the problem. The mole to mole ratio that always comes from the coefficients in the balanced equation. So I hope this last video was helpful. We have 3 videos now on stoichiometry problems and stoichiometry examples. If you need more, you can just drop a comment and let me know.